This is a infinity sum problem from Berkeley maths tournament. So we have the problem as summation n equals to 0 to infinity n cube upon n factorial, and now we need to find it. So what are the steps? So whenever you have this kind of problems where we have denominator as a continuation of factorials, so it somehow reminds me of Taylor series, where we have a Taylor series of E and all. So my goal is to simplify them into a form of Taylor series expansions. From there we can use the value as E and something like that to evaluate. So more or less that will be the thing I will be using here. So first, for simplification, I need to eliminate this n cube, or maybe simplify this n cube, or separate this n cube, so that I can get to a form of Taylor series which are known to me. So now see how I do that. I will write n factorial as n into n minus 1 factorial, because that will help me remove 1 degree. 1 n will cancel out with n cube and make it n square. Now I have n square upon n minus 1 factorial. First see that for n equals to 0 it is nothing but 0, so I am taking from 1. I have removed the 0 part because it doesn't change anything. So now so I have came to this after writing n factorial as n into n minus 1 factorial. Now I will write it as for n equals to 1, it is nothing but 1 upon 0 factorial, that is 1, so it is 1. So I will keep it outside like this 1 plus, and then I will start from n equals to 2. And now why I am doing that, you will know. Just keep a 1 plus summation n equals to 2 to infinity. Infinity is there, I missed that. And this is n square upon n minus 1 factorial. And now I will write this n minus 1 factorial again as n minus 1 into n minus 2 factorial. The same thing that I did here, I am repeating it to simplify it. So that's why, because I did that, taken out that 1 here and started from n equals to 2, because if I have kept the 1 here, then this n minus 2 factorial will be undefined. We don't know the factorial of 1 minus 1 factorial, at least I don't know that. So from here you can see that why I did the taken out the 1 and started from n equals to 2. So again I am writing this as n minus 1 into n minus 2 factorial. Now after writing this as, you can see that it will become n square upon n minus 1 into n minus 2 factorial. Now if you see this n square upon n minus 1, so here I want to simplify things, because if you see this 1 upon n minus 2 factorial, if I can separate it out as a separate summation, it is the Taylor series, or it can be found, its value can be found using the Taylor series. So I just need to simplify it. And now this is to simplify this, we use the technique that plus n minus n, or plus 1 minus 1, or something like that. This is a standard kind of technique if you are familiar with infinity sum problems, or you solved Olympiad questions, so you will get to it. So now I will write n square upon n minus 1 as this. This is the standard kind of simplification technique. So I will write plus n minus n, and now separate it out and see that n square minus n will cancel out with n minus 1, and it will be nothing but n plus 1. And now again, if you can write it as n plus n upon n minus 1, that it can be written as, because if you separate it out as this, so n will remain, and from here n upon n minus 1. And again in n upon n minus 1 I am writing minus 1 plus 1. From there we will just separate it out, n minus 1 will cancel out, and we will have 1 upon 1 plus 1 upon n minus 1. So this is the final that we get after doing these two steps. Fine. Now I will write n square upon n minus 1 as this, the simplification. Now this n minus 2 factorial outside, so you can see that after combine this n minus 2 factorial with this n plus 1, so it will get n plus 1 upon n minus 1 n minus 2 factorial, and if you combine n minus 1 with n minus 2 factorial, it will be nothing but n minus 1 factorial. So this here as I told earlier, the goal is to separate it as a separate summation n greater than equals to this, and in 1 upon n minus 1 factorial. Now this is standard Taylor series, or it can be simplified using Taylor series. Now how it can be simplified, if you are not aware with it, I can just explain it in brief. So 1 upon n minus 1 factorial for n greater than equals to 2, it can be written as this till infinity. And now the Taylor series for e to the power x is nothing but this 1 upon 0 factorial plus 1 upon 1 factorial till infinity. Now if you see from second term to the last, this is nothing but this, so I can write it as e minus 1. If I take this 1 upon 0 factorial with it nothing but 1 to the left hand side, it will get e minus 1 equals to this, so this is nothing but e minus 1. Okay, so this value is simplified as e minus 1, so I will write it as e minus 1 here. And now this is the part that we need to work on. So to develop it into a similar kind of thing, again the steps are kind of similar to it, similar to the previous steps, because this is the same thing that we use in infinity sum problems. Now I will again write n minus 2 factorial as n minus 2 into n minus 3 factorial, and I will start from 3, and I will take the first one. For n equals to 2, it is nothing but 3 upon 0 factorial, it is nothing but 3, so I will take the 3 out, and from here you can see that plus 1 and minus 1 cancel out, so it is nothing but e, and 3 from here for n equals to 2, and I start for n equals to greater than equals to 3. And why I am doing that? Because for n equals to 2, this will be not defined, so that's why I have taken the term of n equals to 2 out and starting from n equals to 3. But this was the I have used in previous steps also, and this was the main thing here, that plus n minus n was the standard, but to observe that for n equals to 2 it will be undefined and start from 3, that is the real deal. Or it could be simple, but yeah. So now we have this, and again I will write n plus 1 upon n minus 2 as 1 plus 3 by n minus 2. This is again a standard simplification by just applying plus 3 minus 3, because I have you can see it. I have written plus 3 minus 3, and from there we will cancel out n minus 2 and 1 plus 3 minus n minus 2. This is the standard we use in infinity sum to cancel things out. So now again combine the n minus 3 factorial inside the bracket. Again you will have 1 upon n minus 3 factorial. This is again somewhat can be simplified by using the Taylor series for e to the power x for x equals to 1, and here we have 3 upon n minus 2 factorial. This again can be simplified using that. So yeah, we had to do this division, this step around somewhere 3 times. Because we had 3 in the power of n in the original question, if you can see that. So to simplify that, we somehow break down it into 3 steps using this division equations, and now we are here, and we don't have any n in the numerator. Now it is easily solvable. So if you see this, it is nothing but e, because for 1 upon 0 factorial plus 1 upon 1 factorial plus till, so it will be nothing but e, so I have written as c. And this one, if you take the 3 out, it is nothing but e minus 1, because it is from 1 upon 1 factorial to 6, so 1 upon 0 factorial will be missing. Again you can use the expansion of e as the Taylor series. And now just simplify this, 5e as the answer.